Now we're going to look at the volume of a sphere. The volume of a sphere has the formula 4/3 pi r cubed. 4/3 pi r cubed. So here we've got a helium-filled balloon. How much helium does the balloon hold? So we can see it's got a diameter of 72, which means it's got a radius of 36. Radius is the only thing that you need to know to figure out the volume of a sphere. That's all it has is a radius. So volume 4/3 pi times the radius cubed. So multiply that out. We'll use 3.14 for pi. One 33.12 cubic feet. But it doesn't ask how many cubic feet, it says how much helium does it hold. Round to the nearest tenth, 1 gallon is 0.1337 cubic feet. So that's our conversion factor. Right now we have cubic feet in the numerator, so in order to cancel that out, we need a cubic feet in the denominator. So this 0.1337 goes in the denominator with 1 gallon up top in the numerator. So you do that, cubic feet cancels out. We're dividing our 195,333 divided by 0.1337. It's going to get larger. You get 146,0980.703, and that's now how many gallons of helium it holds. Now let's read what it said here. How much helium to the nearest 100 gallons does the balloon hold? So to the nearest 100 gallons, we're rounding right here, nearest 100. That's 1, 4, 6. The 8's going to round the 9 up. So rounding to the nearest 100 actually rounds us up to 1,461,000 gallons. A spherical water tank has a diameter of 27 meters. So the first thing we need to do is take that and convert that to a radius. How much water can the tank hold to the nearest liter? And then we're told that 1,000 liters is 1 meter cubed, 1 cubic meter. So find the volume of the tank in cubic meters first. Volume equals 4/3 pi r cubed, radius cubed. Multiply that out, use 3.14 for pi. You get 10,300.77 cubic meters. And then to find the capacity of the tank to the nearest liter, 1,000 liters is 1 cubic meter. So just write it out as a conversion. So we need the 1 cubic meter in the denominator, so it will cancel. So 10,300,770 liters. And just like any other figure, we could put a couple of them together and find a composite figure. So we have a hemisphere, half of a sphere, on top of a cone. We need to figure out the height of this cone so we can figure out the volume of the cone. We already know the radius of both the cone and the sphere. So if this side's 5, the hypotenuse is 13. We find the other side by doing Pythagorean theorem. Better yet, you recognize a Pythagorean triple as 5, 12, 13. So the other side's 12. If you didn't do that, then you would have 13 squared equals 5 squared. Solve it out, you still get 12. So the height of the cone is 12. We find the volume, 1/3 pi radius squared times the height. And we're also going to find the hemisphere, the half of a sphere, which is, if it was a whole sphere, it'd be 4/3 pi times radius cubed. It's half of a sphere, so you divide that by 2. So the cone is 314 cubic centimeters. And the hemisphere is 261.667. So for the entire figure altogether, you add that up and you get 575. So it's to the nearest cubic centimeter, so let's round that up to 576. Now we're going to look at a cylinder that has a hemisphere kind of cut into it. And it says the bottom of the hemisphere is tangent to the base of the cylinder, so that means it just barely touches down there. So since this is a cylinder and a sphere, we need to know the radius. We're told the diameter is 7, so the radius is 3.5. And if the hemisphere if it's tangent to the base, that means that that same radius just barely touches there, so the height is also 3.5. Do our cylinder, which is pi r squared times the height. And we just said the height's 3.5. And then we have the half of a sphere, the hemisphere. Formula is 4/3 pi radius cubed. And it's only half, so we're going to divide that whole thing by 2. So we'll use 3.14 for pi to get our cylinder's volume, 134.6275. And then, again, using 3.14 for pi. You get about 89.752. And we are subtracting because the hemisphere is cut out of the cylinder, so we subtract that. So 44.876, the nearest tenth. So let's change our rounding here. That would round up to 0.9.